Okay, rather than go over this in class, I'm going to just go through the exam from October 7th, 2015 on slides. There were actually two versions of this exam, and I've interleaved them here. So this first problem gives you 4 different sets. Actually, no, 3 sets and I guess what looks like a string. So if we take a look at this, we have a set that contains 4 elements, A, B, C, and D. Another set, set B, contains 1 element, which is just A, B, C, D all squished together, all concatenated. C looks like it's a string from what we'd call it. It's a bunch of symbols concatenated, but there's no set symbols. And D is a set that has 1, 2, 3 elements, the element A, the set containing B, and the set containing C and D. So we start out by asking whether A and B could be alphabet, strings, or languages. Could A be an alphabet? Well, sure, an alphabet is a finite set of symbols, and there's our finite set of symbols. So, sure, A is an alphabet. Could A be a string? Well, a string is not a set, so a string is a finite set of symbols concatenated together. And if we look at this, it's not a finite set of symbols concatenated together. So could A be a string? Nope. But could it be a language? Sure, it could be a language that has exactly 4 strings in it, right? It recognizes the language that has the strings A, B, C, and D. They're short strings, but they're still strings, so yes, it could be a language. If we look at B, could it be an alphabet? Well, no. We think of this as 4 symbols concatenated together, not a single symbol, so no, it's not an alphabet. Again, B is not, well, B is a set, so it can't possibly be a string. And could it be a language? Yeah, it's a boring language. It has exactly 1 string in the language, but that's a language, so sure, B could be a language. The next question is C an element of B? So do we find this item, ABCD, the string ABCD, inside of this set? And the answer is sure, that's exactly what the set contains. So sure, it's an element, but it's not a subset, because in order to have a subset, you need 2 sets. The left-hand side and the right-hand side both have to be sets for something to be a subset of something else. So no, C is not a subset of B. And then the next line says, let F equal A union B. Express F as a single set in the box on the right. So A union B just means combine everything that's in there. So we've got A, we've got B, we've got C, we've got D. I'm not going to be able to fit it in here with my stylus, but you'll have to bear with me. And then we have also the string ABC. And if we keep going, could F be an alphabet? Well, is it a finite set of symbols? No, because we have this symbol in here, A, B, C, D. Sorry, not the symbol, the string. So could F be an alphabet? No, F couldn't be an alphabet. Can it be a string? No, it's a set, so it can't be a string. But could it be a language? Sure, it could be a language. And then it says let G equal A intersect D. So let's just take a look up here. A is 4 different symbols in the set. D is the symbol A, the set containing the symbol B, and the set containing the symbols C and D. So when we intersect that, all we are left with is A. So if we go back up here, G is just the set containing A. Could that be an alphabet? Sure. Could it be a string? No, it's got set symbols. Could it be a language? Yes. Again, a boring language, but a language. Okay, so this is problem 1 from the other exam. Very similar. We've got 4 sets again. Actually, we have 4 sets this time. A, B, C, D, E, F. So we've got a bunch of symbols. We have a set that has a couple of strings. we have a set that has one string, and we have a weird set that has a set in it, the symbol C, another set, and the symbol F. So could A be an alphabet? Well, sure, it's just a finite set of symbols. Could it be a string? Nope, it's a set. Could it be a language? Absolutely. A boring language. It's a language that has 1, 2, 3, 4, 5, 6 strings in it. And each of those strings is a single letter, but it's fine. As for B, could B be an alphabet? Well, no, it's got strings in it, right? So B is not an alphabet. B is also not a string, but it could be a language with just 2 strings in it. Is C an element of B? Well, now we're asking whether the set containing AB can be found in here. And while AB can be found in here, the set containing AB cannot be found in here. So we have to say, no, C is not an element of B, but it is indeed a subset. They're both sets, and everything that is in the set C can also be found in the set B. All right, now we have to express F, which again is A union B, but we're taking the union of slightly different things now as a single set in the box on the right. So let's see. Again, I'm going to have to run out of space here and move outside the box, but we've got A, B, C, D. Let's slide over a bit. And we also have E and F. And then in addition, we have the elements of B. So that would be A, B, and C, D, E, F. And there's our set. And maybe I'll just kind of cross out that set symbol there. Okay. And then could F be an alphabet? Well, again, F has some strings in it. So no, F is not an alphabet. It's not a string because it's a set. But could it be a language? Absolutely. Now we need to take the intersection of A and D. And if we look this time, if you look at D, it has 2 individual symbols, C and F, that are inside of A. So the intersection, the things that A and D have in common, are C and F. And could that be an alphabet? Sure, that's just individual symbols. String, no. Language, sure. Okay, so now we're trying to find a language. I said a set of strings to describe each of the following regular expressions. Now, if you want, for many of these, you can express these as an infinite list, and you could get full credit for doing so, but if you did so, you really had to make sure that you gave a pattern that I could understand, and that your pattern had an order. And typically the only order that we've really talked about in class and that anybody's ever come up with that seems to work for the kinds of things that we do is from smallest to largest. So let's do this 2 ways. The easiest way to do this problem is to just directly turn it into strings. So here we have A plus B star. That means as many A's or B's as you want in any order, right? And we said when we talked about sets that we can write that as A comma B star. And that is concatenated with C star. So if we want to turn that into a language, we just have to turn that into a set. So that's the easiest way to do this, set. Another way that you could answer this question is to try and list everything that's in there. So you could say, all right, well, lambda's in there, right? And then what strings do we have of length 1? Well, we could have A by itself, B by itself, C by itself. What do we have of length 2? Well, now it can be any combination of A, B's, and C's where the A's and B's happen and then the C's happen. So it's kind of hard to list all these, but you can think about it. So let's see. So we've got just A's, we've got A's and B's, we've got A's and C's. That gets rid of everything that starts with an A. We've got, let's see, things that start with a B. Well, you could have BA, BB, and BC. And then things that start with a C, well, that has to just be CC, right? Because you can't have any of the A's and B's after the C, just before it. And then now it would be appropriate to start going on to strings of length 3, so I might take all these strings of length 2 and try and put an A in front of it, and that's okay. I can't put a C in front of all of them, of course, right, because the C can only come at the end. So, you know, we can start doing things like AAA and AAB and so on. And if you actually gave me at least this much, you got full credit. Okay, so let's keep going. If we do the second one, this is any strings that start with an A, B together, right? And any number of A's and B's together, and end with any numbers of C's. But the A's and B's have to be squished together, right? So now we're talking about strings like, if I'm looking at this one for a minute, we're talking about strings, again, lambda is in there. The only singleton in here is C, because after that we have to squish the A and B together, right? So AB is a string of 2, CC is a string of 2. If we want strings of 3, it has to be ABC or CCC, and so on. I'm not going to keep going with this one. But again, it's much easier to just say, okay, well, it's as many ABs. Notice there's no comma in here now, right? So AB star concatenated with a set C star. Okay? So let's keep going. Now we've got A star, B star, C star. And this is as many A's as you want, followed by as many B's as you want, followed by as many C's as you want. But they do have to come in that order. So if we are trying to show this set, then we need to say, let's see, we still have lambda in there, then we have A, B, and C by themselves, and then all the pairs have to have the A's before the B's before the C's. So let's see, we could have like AA or AB or AC or BB or BC or CC, and I think that's all the 2's, right? And finally, this last language is the language that just has the empty string in it. And if we want to express that as a set, it's just the set containing lambda, right? And if you look back at our book, you'll see that they talk about how to go between regular expressions and sets, and lambda is one of, lambda and the empty set are possibly the ones that are gonna trip you up, and that's what you get for lambda. And then problem 3 was one of these use your wits. Can you figure out if you multiply or concatenate this set with the set M, you get this set. So what is the set M? And if you mess around with it for a little while, what you find out is that M is the set lambda A, B, and AB. And we can check our work, right? Because we can say, okay, let's just go through each of these. If I multiply each of these things by lambda, I just get those things. So A, double A, and AB are in that set. If I choose the element A from here and multiply everything in here, sorry, concatenate everything in here with an A, what do I get? Well, I get AA, which I've already crossed off, but that's okay. I get a AAA and an ABA. So let's cross off the AAA and the ABA. If I concatenate everything with a B on the end, I get AB, AAB, and ABB. So let's cross them out. Well, AB is already crossed out, but that's okay. AAB and ABB. And finally, if I concatenate everything with an AB on the end, I get AAB, double AAB, and ABAB. So AAB is that one, double AAB is that one, and ABAB is that one. So indeed I did figure out the right set here. This next page is very similar to the previous one. Of course, this is, these are two exams I gave on the same day. I'm trying to make them fairly similar. I'm not going to go in quite as much depth about the longhand way to write these sets, but if we look at this first one, it's A star followed by, so 0 or more A's followed by as many B's and C's as you want in any order. And you can represent that as the concatenation of the set A star with the set containing the two elements B and C starred. If you want to do this one, this is 0 or more A's followed by 0 or more BC's where the BC has to be, the B's and C's have to come together, but we can represent that as A star, right? The set containing A starred followed by the set containing the singleton BC starred. Right, another way that some people chose to do this one, which is perfectly valid, is to say, okay, it's the set of all strings that start with 0 or more A's and are followed by 0 or more BC's, and of course the A's and BC's, the number of them doesn't have to match, so we say such that N and M are in the natural numbers, right? So that's another perfectly reasonable way to represent this set, all right? A star, B star, C star we did in the other, on the other page. And over here, this one is, again, kind of the one you just have to know. The empty set as a regular expression represents the empty set. So that's how you translate it. Down here, problem 3, use your wits to solve this problem. In this case, we are starting with our set M and then concatenating that with this other set. And again, if you mess around with it for a bit, you end up, realizing that the set lambda, comma B, double B, and BA seems to work here. So if we take a lambda and squish it, right, concatenate it with a B, a BB, or an AB, that gives us B, BB, and AB. If we take the B and we put that in front of each of these, that gives us a BB, a triple B, or a BAB. So let's see, there's our double, there's our triple, and there's our BAB. If we concatenate everything with a BB in front of it, that gives us a triple B, quadruple B, and BBAB. So we can say we got that one. There was our triple B, quadruple B, and BBAB, right? And finally, if we put a BA in front of each of these three things, we get BAB, BABB, and BAAB. So let's see, we've got BAB, that's fine, we already got that one, but it doesn't matter, it's a set, right? So it can appear multiple times in the set. BABB and BAAB. So sure enough, it works. In this problem, we are taking sets and turning them into regular expressions, so kind of the opposite of what we were doing in problem 2. Here we've got the union of two sets. This is just a finite set that has three elements in it, three strings, right? A could be considered a string as well as a letter of the alphabet. And we're taking the union of that with the set of all strings that have 0 or more G's in it. And we can represent that as a regular expression pretty easily. We can just say that's A plus BC plus DEF plus G star, right? And remember, plus in the context of regular expressions means or. So this language is the string A, or the string BC, or the string DEF, or 0 or more G's, right? All of those strings are elements of the language. For the second one, A to the N, B to the M. So as many A's as you want, as many B's as you want, as long as N and M are in N, and also, let's see, N is greater than 3, and M has to be between 2 and 5. So it's worth noting the only numbers between 2 and 5 are 3 and 4. So this says we have to have either 3 or 4 B's and as many A's as we like, as long as there's at least 4 of them, right? So what do we need to do? We need to say, well, there has to be at least 4 A's, right? So 1, 2, 3, 4, and then 0 or more after that. And we're going to concatenate that with a string of either 3 B's or a string of 4 B's. So we could say that times BBB plus BBBB, and that would work. Part 3, all strings that start with an A and end with a C. So we know that we have to start with an A, we have to end with a C, and we're over the alphabet ABC, so we can just say stick an A or B or C and as many of them as you want in the middle. So again, start with an A, have as many A's and B's and C's as you want in the middle, 0 or more of them, and end with a C. For the question, all strings of length 3, you could say, well, there's 27 of these, and you could actually list them over the alphabet A, B, C, and you got full credit if you listed them. But that was too much like hard work. The other way to say it is start with an A or B or a C, concatenate with that with another A or B or C, and concatenate that with another A or B or C, and you're done. And the last one here says all strings of any length that are composed of at most 2 different symbols. So you can't have all 3 symbols, but you could have just 1 symbol, you could have no symbols, or you could have any 2 symbols. So we could say, well, let's see. Here's all the strings that have just A's and B's. That also, of course, contains all the strings that have just A's and all the strings that contain just B's. And so strings in my language could look, could look like this, right? Or there's our plus sign again. They could look like this. They could have as many B's or C's as we want, but no A's. Or they could have as many A's or C's, but no B's. Okay? And problem 5. Your best friend draws you a correct DFA that contains exactly 300 states over this long alphabet that accepts the language Q. Is it possible to draw another DFA that has 325 states that will also accept the language Q? So what you have to imagine is that your friend has kind of drawn you some DFA. There's our DFA. And the question is, can we add 25 states and still accept the same language? And the answer to this question is definitely yes. And you needed to convince me somehow that you understood how to do that. Probably the most common way people answered, and what I expected people to say was, look, I can just add 25 more states, right? So let's just draw a few here. As long as each of these states isn't connected in any way to my main DFA, right? So I won't change the DFA my friend gave me at all. I'll just take each of these states and do a self loop that has all the symbols 0 through 9 in it. And I'll do that for all of these extra 25 states. You know, colloquially, we called these trash states, right? But they're not even trash states, really. They're just kind of states that are floating out there. But if you talked about we could just add 25 trash states, that's fine. If you talked about 25 disconnected self-looping states, that's fine. So here are the questions I gave to the other section of the class. The first one is, again, the union of some sets. In this case, it's the union of 3 sets, 0 or more A's, unioned with a couple of sets with just finite numbers of strings in them. And so this is going to be A star plus BC plus AC plus BB. And some people, you know, combined these guys together. So you could write something like A star plus B times, oops, no, not B. Well, I guess I can actually combine this one and this one. So I could say B times C plus B, right? B concatenated with, I say times, but B concatenated with C, or B concatenated with B, or the string AC. You could do something like that if you want, right? You can see that this problem is very similar to the other one. It's just in this case, we're limiting the A's. You could have 2 or 3 A's, and again, you have to have at least 4 B's. So I might write, let's see, 2 or 3 A's followed by at least 4 B's. So 1, 2, 3, 4, but we can have more than 4 if we want. All strings that contain the symbol B but don't start or end with a B. So they have to have a B somewhere. They have to start with either an A or a C. And then after that, they can have as many A's, B's, and C's as they want. So you could have A plus B plus C star, as long as you have a B. And then again, after that, as many A's, B's, or C's as you want, as long as we end with an A or C. So that was what I was looking for. A few people came up with something that was ever so slightly more elegant. They said you start out with an A plus C, and then you can have as many A's or C's as you want, right? Eventually you have your first B. After your first B, you can have as many A's or B's or C's as you want. But you do need to end with an A or a C. So that's a slightly more elegant answer, but they're both perfectly fine. All strings of length 3, we did that one, and composed of 2 different symbols. So these 2 questions were actually the same on both exams, and similarly, this last question was the same on both exams. Oops, I don't know how come that ended up there, but that's okay. All right. So here we've got this question. Some friends started to draw a DFA but had to stop before they finished it. The picture they drew is shown below. And the first question is this picture a DFA? So let's take a look at it. We just need to know, is it a DFA? Well, it has a start symbol, right? It has a bunch of states. And if you look at the graph carefully, well, at this, it's more than a graph, right? Because it's got this start thing going in there. But if you look at it carefully, you can see that it has a bunch of directed edges, and out of every single state there is an out transition for A and an out transition for B. The one thing that you'll notice is there's no double circles on this, right? So there's no except states on this. But that's actually okay, right? You don't have to have an except state. If you don't have any except states, that means that this doesn't actually, the language that this DFA recognizes is the empty language. It doesn't accept any strings whatsoever. So it recognizes the empty set, but it still counts as a DFA, right? So if we go back up, the question is the picture as drawn below a DFA? Yes, it is, right? It's a DFA. I haven't told you what it's a DFA over, but you can figure out it's a DFA over the language A, or the alphabet AB, right? But it is a DFA. It's definitely a DFA. And if the picture is a DFA, what language does it recognize? Well, we said it recognizes the empty language, right? And notice that the empty language is not the same as the language containing the empty string, right? This first language has nothing that it accepts. No matter what string you throw in, it rejects it. The second language, if you give it a lambda, it accepts it. It says, yes, that's in my language. So this is not the correct answer. Similarly, if you say the set containing the empty set, well, that's a language that accepts the empty set, which doesn't make sense. So that's not right either, right? So we keep going, and the problem says it turns out that your friends were trying to draw a DFA that recognizes this language. So it's language AB star plus this quantity AB star over the alphabet AB. And your friends say the only thing they forgot to do was to indicate which states were final states. And I tell you your friends are correct. By adding some circles around some of the states, this will be a DFA that recognizes the above language. And I say fix the picture for them as follows. Add an extra circle around those states that need to be final states in order that the diagram will represent a DFA to recognize the language AB star plus AB star over the alphabet AB. You say that out loud and it doesn't make sense, but or it's not clear, right? But it's, let's look at this language for a minute. Let's just think about the language. We have an A, the language of as many, well, one A followed by as many B's as we want, right? So if we're just trying to look at some of the strings in this language, the strings in this part are the set A, AB, ABB, oops, ABB, ABBB, and so on, right? And the strings in this part are 0 or more ABs, where the ABs have to be together. Here, maybe I'll write them over here. So that would be, you could have 0 of them, you could have 1, you could have 2, right? 1 pair of ABs, 2 pairs of ABs, AB, 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 and so on. And we need to take the union of those two sets in order to have this language. So let's see if I can shrink these guys a bit Get them out of the way a little bit so that you can see. That's not so good, is it? There we go. So you can see that, but you'll still see the DFA a little bit better. So if we look at this first set of strings, we have to recognize the string A. So we have to accept the string A, excuse me. So if we start, we have to accept the string A. So that absolutely has to have a double circle. We also have to accept the string AB, so AB, notice, right, the start is here, so A then B, so we have to have a double circle around 5. We need to accept ABB, so ABB, double circle around 6, and then you'll notice that 6 has this B loop here. Right, so once we get to 6, we'll add as many B's as we want. So we've taken care of that first part of my language. Let's look at the second part of my language. I need to accept the empty string, so that means I start and I immediately accept. I need to accept the string AB. Well, I dealt with that, AB. But then I need AB. So let's see, AB, AB. So 7 has to be an accept state. And I have to keep accepting ABs, so AB, look, so there's my loop. So there's the final answer to this problem. 1, 2, 5, 6, and 7 have to be accept states in order for this to be a DFA that accepts that language. Problem 6 on the other exam has same kind of question. The transitions are a little bit different here. The language we're going to accept is a little bit different. But still, you know, is it a DFA? Yes. No accept states, so it accepts the empty set. And now what we're trying to do is we're trying to add double circles so that we recognize the language AB star plus A star B star over the alphabet AB. So let's just, here's the language again. Written right here, right? AB star plus A star B star over the alphabet. So again, let's just think about the two pieces of this regular expression separately. Let's start with AB star. Well, AB star, is that what we saw in the last one? That is an A by itself, or an AB, or ABB, or ABBB, and so on. And if we look at this A star B star, that's as many A's as we want, followed by as many B's as we want, right? So that would be let's see, so lambda's in there, right? Because we could have 0 A's or B's. We could have an A by itself, a B by itself, 2 A's, 2 B's, an A and a B. We could have a bunch of 3's, right? So we could have 3 A's, we could have AAB, ABB. We can't have ABA, right? We could have BBB, right? Is there anything else we can have? I don't think so, because all the A's have to come before all the B's. So there you go. Right, just to clarify, it is an infinite set, right? But these are the only strings of length 3 we can have in there. So let's go through these and see what we have. We need to accept the string A. So if we start here and we see an A, we have to accept state 1. We need to accept the string AB, so AB. So we need to accept 5. We need to accept ABB, so that would be A, B, B. So that's 6. And then again, once you get to state 6, you can see we've got this loop, so we've got all our ABBs covered. So we have this first part done. And now we need as many A's as you want, followed by as many B's as you want. So if we kind of go through the things we've listed here, we need to accept the empty string. So again, our start state has to be an accept state. We need to accept an A by itself. Well, that's okay. We also need to accept a B by itself. Well, we've got that one covered. We need to accept two A's, so there's an A, okay. And in fact, we need to accept kind of two A's followed by any number of A's, right? And we're set here because we've got A, and then as many A's as we want. We need to accept two B's. Well, let's see, there's my B, and another B, as many B's as we want. So we're good here, right? We've got strings of all A's and strings of all B's, we're good. We just need strings that now start with a bunch of A's and then have a bunch of B's following them, right? So if you have no A's, we're good. That's the all B's. If you have one A followed by a B, that's fine. Another B, that's fine. And there's our infinite B's after that. So if you have 0 or more A's followed by 0B, 0K, if you follow it with 1B, I guess we need to circle 7. And if you have some A's followed by at least 2 B's, you end up here, so you're good. So there's the final answer for this one. You had to circle states 1, 2, 4, 5, 6, and 7. Okay, for problem 7, I give you a DFA, and you need to start out by telling me what language does it recognize. And this is one of those use your wits things, right? So you need to just kind of look through this thing and say, how can I get to the accept states? So you look, and there are two final states, two accept states, 4 and 3. So let's start with 4. We can get to 4 by having the string C, and it looks like that's the only way you can get to 4, right? There's no way to get back here except to just start and go to 4. So this piece is pretty easy. This piece is just the regular expression C. And if we want to figure out what this other piece is, there's the accept state. How do you get there? Well, there's a couple paths, right? You can go up that way, or you can go straight across. But it looks like if you get down here, in fact, 5 and 6 are what we would call trash states. Once you get to state 5 or 6, you're kind of stuck in this 5, 6 area. So if you go straight across, you start with an A or a B, then you have an A or B or C, and then as many A's or B's as you want. So let's see, that would be start with an A or a B, then have as many A's or B's. Oops, no, sorry, then have an A or a B or C, and then it's as many A's or B's as you want. Right, where that's A plus B star. And the other route to get there is to have a C, and then an A or a B, and then as many A's or B's as you want. So the other route to get there would be to have a C, followed by an A or a B, followed by as many A's or B's as you want. And yeah, just to clarify, that star there is outside, right? Maybe we should redraw it just so the grader knows exactly what we're talking about, right? And actually what's interesting about this language, if you look at it, and you didn't have to do this. This was, this regular expression is fine. If you look at this regular expression, it turns out that you have a C with nothing after it, or a C with an A or a B followed by 0 more A's or B's. So we can actually combine these two pieces. We can combine that with that, if you want to simplify this slightly, to get a C followed by 0 or more A's or B's. Now, strictly speaking, I did ask for a language here. What language does it recognize? I didn't take off points if you gave me a regular expression, but even better if you give me a language. So let's see, what is the language? The language is, it accepts the singleton C. It also accepts a C that is immediately followed by an A or a B, right? We got concatenation going here, immediately followed by an A or a B star. And we can union that with, what was the other part we have here? We have an A or a B, followed by an A or B or C, followed by A or B star. So we can just write that out in set notation. Let's see if I can show you all this at once. So it's unioned with an A or a B, concatenated with an A or a B or a C, and that whole thing is concatenated with an A, B, or a C starred. So if you want to write it as a set of strings, you can do it this way. You know, we generally allow, we talk about languages in terms of sets of strings and also in terms of regular expression. So the regular expression answer was perfectly fine, but set of strings, if you wanted to give me that, is fine too. And then the second part of this problem asks to give the 5 tuple that represents this DFA. And as you, of course, remember, the 5 tuple contains, let's see, what's in the 5 tuple? It's a tuple, so we have round brackets. And it contains, it starts out with the set that has what my states are. Then it gives me my alphabet. It gives me my transition table. Tells me what's my start state and what are my final or accept states, which is a set. So let's see what happens. Can I shrink this a little bit? There we go. So I can put my DFA up there and we can work on this. So there we go. So let's see. My states is a set, and we have the states 1, 2, 3, 4, 5, and 6. My alphabet is also a set. This is over the alphabet A, B, C. My transition table, I'm going to write as T, and then I'll just detail what my transition table is here. So let's see. So I'll say T is equal to, let's kind of make a little bit of a space here so we can do this. T is going to be a table we're going to have 1, 2, 3, 4, 5, 6 are my states, and we have the alphabet A, B, and C. So let's see. If we are at state 1 and we see an A or a B, we go to 2, and if we see a C, we go to 4. So for A and B, we go to 2, and for C, we go to 4. For state 2, we go to state 3 no matter what. So state 2 goes to 3 on an A, 3 on a B, and 3 on a C. State 3, we stay at state 3 for A and B, but we go down to state 6 for a C. Oh yeah, there was a typo in this exam. There should have been a C right there, and I announced that in class during the exam. So we have that in state 3 on A and B, you stay in state 3, but on C you go to state 6. And if you are at state 4 on A and B, you end up at 3, but on C you end up at 5. State 5, no matter what you do, you go to 6. State 6 stays at state 6 for a B, but goes to 5 on A and C. So there's my transition table. So let's keep going with my 5 tuple. I had my states, my alphabet, my transition table. I need to tell you my start state. It's getting pretty small here now, but if you look, my start state was 1, right? And my accept states were 3 and 4. So let's just fill that in here. My start state was 1, not a set, just a singleton. You only ever have one of those. But my final states, my accept states, 3 and 4. And of course, it's our 5 tuple. You wouldn't have your 5 tuple if you didn't end with a closed paren. Here's the language the other class got. Let's see, what does it accept? It accepts the string A and B by itself. It accepts an AB followed by ABC followed by as many ABs as you want. So far we've got, it accepts, let's see, it accepts an A or a B by itself, or an A or a B followed by an A or a B or a C, and then that can be followed by as many A's and B's as we want, right? So that's this first path. We've also got this path down via C, right? So it takes a C followed by an A or a B and then as many A's or B's as we want. So let's see. It's going to take A. We'll add to this language a C followed by an A or a B followed by A plus B star. Oops, there we go. So let me shrink this so we can see it a bit. And of course, if you wanted to, you could represent this as a set of strings. So you could also, let's see, what's the set of strings? We've got A and a B unioned with AB concatenated with ABC concatenated with AB star, and that whole thing unioned with a C concatenated with an A or a B concatenated with AB star. Right, so two perfectly reasonable answers. And then we're asked to give the 5 tuple that represents this DFA, and our 5 tuple is going to be very similar to our previous one. Let's see if I move that over. We have for our 5 tuple the set of states, so that's 1, 2, 3, 4, 5, 6. How'd the 5 not work there? There's my 5. My alphabet, which again is A, B, C. We need to give my transition table T, but if I'm not mistaken, the transitions on this graph are exactly the same, or on this DFA are exactly the same as the ones on the previous problem. The difference is that the accept states are different, right? So I'm not going to write that out again, but I will. Let's see, can we shrink this a bit so I have a little bit more room to do my 5 tuple? Then we need our start state, which is still 1, and the big difference in this DFA is that now our accept states are the states 2 and 3. And finally, the final question was a proof. We had to prove that these two regular expressions were actually equal using the properties of regular expressions up here. And there were two things you had to do. You had to write, you had to, figure it out, and then you had to write it out formally as a proof, right? So I'm not going to show you the figuring out part, but I will show you what I was looking for in a proof. I'm going to assume that you actually, have the textbook, so I'm not going to leave you to look at this the whole time. So let's move this up a bit. So what we want to prove is the equality of these regular expressions. The easiest way to do that is either to start with this one and show that it equals this one, or vice versa. I'm going to start with this one. It was perfectly fine to start with the other one. I also gave you this hint. I said at some point you may find it useful to prove that AB star is equal to A plus AB star. You need to prove this, not just to assume it, right? So let's do our proof. If you want to get very formal, you could write what you want to prove again, right? What do I want to prove? I want to prove that A times B star plus C plus D star is equal to A plus AB star plus AC plus D star. Okay, and we have that here, right? So let's get started. I'm going to state the left-hand side of this equation. So I have A times B star plus C plus D star. And line 1 of my proof, I'm going to say that that thing up there is equal to, and I'm just kind of formatting it like this because of my space requirements. You could write all of this on the same line, right? You could have this thing equals and then your statement here, but you do need to tell me where am I starting. I'm starting with this, and that is equal to. I'm going to start my proof by multiplying out this piece. So I'm going to say that's equal to, maybe I should say distributing rather than multiplying out. That's the same as AB star plus AC plus D star. And my reasoning, I need to tell you what's my reasoning for this. And my reasoning, if we look up in my properties here, is if I look at the properties for distributive properties here, right? We've got that if I have R times S plus T, that's the same as RS plus RT. So that would be, in the terms of the language we've been using in class, that's 3.1, right? So distributive 3.1, or you could just write 3.1. So we will write, my reasoning is distributive property 3.1. Okay. Now I gave you a hint that said you may find it useful at some point to prove that AB star is the same as A plus AB star. And look, I suddenly have an AB star, so maybe I want to figure out a way to move that into A plus AB star. And you can't do that in one step from the rules up above, as far as I can tell. I don't see any properties that tell me that I can do that in one step, but I can do it in a couple of steps. So here's how I chose to do it. I'm going to work on this B star piece for a minute, and I'm going to say that B star, according to the rules up above, is the same as lambda plus B star, and I can see that right in here, b star is the same as lambda plus b star, right? Because r star equals lambda plus r star. Notice that this rule 5-2 gives me a bunch of different things. And we said in class, I'm going to give you the rule, and if there's a bunch of different things on the line, I'm going to tell you which piece of the line I'm doing. So we're going to say line 2 of my proof, that's the same as A times lambda plus B star plus AC plus D star. And my reason for number 2 is rule 5-2, where we used the part that said r star is the same as lambda plus r star. If you didn't give me this last part on the exam, I took a little bit off because I did ask you in class to show me that. So let's keep going. And now I'm going to distribute this whole piece again. So I end up with that being equal to A plus AB star, look at that, plus AC plus D star. And again, we're using exactly the same rules we did in step 1. The reason for step 3 is the distributive property 3.1. So if we compare what we've got with where we're trying to get to, we are almost there. We have the A plus AB star plus AC, right? A plus AB star plus AC. And the only difference is at the end of ours we have D star, and at the end of where we're trying to get to, we have D plus D star, right? So let's go back. So we need to change this D star into a D plus D star, and if we look up at our reasons, it turns out we can see that in here 5-1, D star equals, and well, R star equals R plus R star, so D star will equal D plus D star. So we can go back down. So that was 5-1, and then we had to say R star equals R plus R star. So let's go back down here. I'm not sure where this thing came from, but we'll get rid of that. Okay, so our line 4 is going to be that the thing above equals A plus AB star. And just to make it clear, you don't have to underline this in your proof, but I think it's clearer when you're watching me do this which part I'm changing. Plus AC plus D star. And my reason for step 4, whoops, that's no good. Let's see. There we go, that's better. So my reason for step 4 is by property 5-1, which is R star equals R plus R star. So let's see, I think, yeah, I can squish everything a little bit. All right. So my proof is almost done. I still need to say, look, I'm done. And the way you write look, I'm done is you write QED. There's other ways to write look, I'm done too. But you need to somehow tell me, look, I'm done. So that's it. And both sections had the same proof. So just a couple of notes I made to myself as I was grading to be sure to tell you guys about. The first thing is that it's really important that you tell me where you're starting, right? You just can't write AB star plus AC plus D is done by distributive without telling me where you're starting, and you need to tell me that all these things are equal, right? You need to give me this piece. That's something we said in class. You need to tell me not only the rule, the rule number, but the piece of the rule. I really didn't take off a lot of points if you didn't have that. And the other thing is just the formatting. You can't do this by manipulating both sides of the equation at once to just kind of change this one a bit and change this one a bit and call that a proof. You can do that on your scrap paper. You can take this and see, where can I manipulate that piece to? You can take this piece and say, where can I manipulate that piece to? But when you finally get to your proof, the idea is that you're going to try and make it look just like a whole bunch of steps that you totally figured out from start to finish. So you can convince someone, look, if I start with this, I can end with this, they're all equal. So I have shown you that my statement that I wanted to prove is true.